Welcome back, everybody. Today we are at a cruising height of 33,000 feet. We are looking at a landing in Anchorage, roughly 10:47 p.m. And we are now at cruising altitude. If you have any questions or concerns, feel free to ring the bell, and you are free to move about the cabin.
Okay. So, did you notice anything weird about it? Because I even messed up and I said one word right the first time, and then I said it the wrong way. We're at a cruising height. That's a weird thing to say. Yeah. So it's not like we're getting on a subway. Nope, we don't need that. But do you guys agree it's weird if your pilot said we're at a cruising height of 25,000? That's a weird statement. Now, is height really any different than altitude? No, but the context matters, right? If I ask you about the height of a triangle, you know exactly what I'm talking about. Or if you didn't, you might have a better idea after you looked at the bell ringer there for a minute. Could I call it an altitude and mean the exact same thing? Yeah, like altitude is just how far from the ground. Height is just how far from the ground. Don't know why we use different words there, but we do, just naturally. Now, the good news is I don't really care which word you use, but geometers, for whatever reason, we don't use height. We use the other word. What's the other word? Altitude. So just so you guys know, we are still in 5.3. We have seen 3 centers so far. 3 different types of centers, which is why if somebody says it's the middle or the center, I don't accept the answer. Riley, we made eye contact. Give me one of the 3 centers that we've looked at with triangles by name. I'm going to stand here so I get tan. Give me one of the 3 different types of centers we've looked at. Look at do you have your notes from yesterday? What's the center of the triangle or the place where all of our medians intersect? It's called the what? We named our theorem after it. What's the theorem we wrote yesterday? Hey, the centroid is one of them. Okay, follow up. Ronaldo, you look like you were excited. What's the centroid? It's where what's intersect. Not your bruh. Fam. Yeah. How would you find the centroid? Where all the medians meet. Awesome. Sonny, you looked at me. Give me another center. We have centroids and? So what do you call the center of the inscribed circle? So that would give me my median. And we're asking about the what of the triangle? No. I asked people to name the 3 whats. The 3 centers. It's the in center. There we go. And let's see. What's the in center there, Honor? Good. So like I can draw it. That's fine. So let me rephrase that question. So here's an in center roughly, or here's the in center. How would you construct this without drawing the circle, or even with the circle? It's where the whats meet. Angle bisectors, and it looks like that looks like it would be. Okay, so angle bisectors. There is one more that we're looking at here. Sevilla. Everybody's trying to avoid looking at me, and I'm just looking at who's trying the hardest. Sevilla. And real quickly, we're just going to square this. Do I pronounce your name Sevilla, like Sevilla, or Sevilla? Okay, Sevilla. What's the third one? We have centroid, in center, the circumcenter. And hey, Tristan, good to make just review right now. We have the circumcenter. Tristan, if I wanted to find the circumcenter, it is not the medians, it is not the angle bisectors, it's the I'm going to sketch one, and then without just people whispering to you, do you agree that's a midpoint? Like, would you believe it? What did I just draw? Because it's certainly not a median. It's not an angle bisector. Did I bisect this segment? Like, I'm not trying to trick you, just in case. Did I cut this in half? So it's been bisected. And this is a right angle, but do we have another word that might be perfect for it? Perpendicular bisectors is how we get the circumcenter. Now, for these, they are easy to get goofed up, for sure. I have a hard time remembering them if I'm not like actively in the process of doing these, because they're all super similar, right? Okay, if there was something that you needed on your notes for this or in your note card, like I don't want you guys to memorize a ton of stuff. It seems reasonable that this is what would be in there, and then you could probably say a little bit about the theorems. Do you want to address the theorems real quick, or do you just want to jump into our last center? Okay, I'm going to say the theorems just while we're doing it. The medians, these guys, center of mass. That's my centroid. In center, equidistant from the sides. Circumcenter, equidistant from the angles or the vertex. Okay, our last one, and this is the conclusion of 5.3, second half of it. We talked about medians the other day is where we started. So we better start today by defining and talking about the idea of an altitude. And I'm just going to say altitude, but just to be clear, of triangle. Okay, if you want to draw an altitude, and you can sketch this one if you want, but you don't have to because we're just going to make a comment, but it is going to make it easier for me to talk about. So optional, we'll go with pink. This, I think, is a triangle. Pretty sure of it. And if I just said what side's the base, would we all agree that this is probably what we're going to identify as the base? Because it's sitting on the ground. Now, if I named this A and B and C, if I asked you to find me the height of this triangle and it were setting on the ground, where would you draw the height or the altitude from? So you'd probably drop from B, and then if we let gravity do this, it would drop straight down, and it would form what angle with this horizontal? Now, it's weird that we have to do this. It would be 90, I agree, and it's strange that we have to, but assuming that this thing is sitting on the ground, is it reasonable to say the ground could keep going, like past our triangle? So now I have something to mark my 90 degrees with. What we have just drawn out, this B, down to this point, weird. I'm going to call this D. We have just constructed an altitude. And it's weird to think, depending on the context, it seems weird sometimes that your altitude could be drawn outside. But if this were a mountain and you said, how tall is a mountain? Of course you just go directly underneath and measure up. Like that's a natural thing to do. It gets weird when you start to think about it here. This is the height of my triangle or the altitude. How do we define what just happened? Like you guys all know what a height of a triangle is, I think. Seems that way. How would you write down what we just did? So I'm just going to call it a segment, which it could have a distance for sure. We're going to say the segment from where? From highest point. So could be from here, but could we have done it from this side also? Like if this were the ground, and I'm not going to make us redo it, but I could have drawn my height here and just understand that that extended too, right? Like if this were the bottom, I could have drawn it from any side. I drew it nicely. I'm going to say it's a segment from a vertex. And where do I need to go? No matter what vertex I pick. So straight down only works if it's vertically like this, because I don't think that I would say I went straight down just now. What side does it go to? From vertex to opposite side. Now I'm going to have to put a little note in here. Will it always necessarily actually hit the side? Like this didn't hit AC, did it? So I'm going to put something in parentheses or an extension of, just to say, look, if we need to extend that side out a little bit, we can. A segment from some vertex to the opposite side, or an extension of that side in a, what angle did we form? At 90 degrees. And you could just say perpendicular if you'd rather, but it's 90 degrees. And we might have to extend this out, and that's okay. Doesn't matter if we have to extend it. Now, when we do this, I'm going to pop back over to GeoGebra for just a moment. Do they always meet at the same point? And if you're not sure, we'll go back, because that's okay if you're not sure, because this is a standalone idea. This center that we're after here, and let's go to GeoGebra. These look like altitudes to me. So check it out. Here, all three altitudes happen to meet inside the circle. And they don't mark it, but that's 90 degrees right here, and here, and here. So those are all my altitudes. Do they have to be in the circle? Or in the triangle, I'm sorry? No, they could be, but they don't have to be. But they are always perpendicular to the opposite side. If I extended this straight out and just continued this line, we'd still get a perpendicular here. Okay, so couple things with these. We're immediately going to get right in. They all meet at a single point, and we're just going to sneak this in to our theorem and try to be a little less righty today. Our last theorem of this section is theorem 5.8. And in this theorem, we're going to find our last little piece here. Our theorem 5.8 is known as the orthocenter. Orthocenter theorem. Now, this word feels kind of out of place, and realistically, you probably don't care, but it's a nice place to see some fancy math language that you've never seen before. Perpendicular just means 90 degrees, right? And if I asked you to form 90-degree angle, you're probably going to do it with a line and a line. We're in 2 dimensions. 2 lines is what we use to make a right angle. Could I launch straight off Earth? Like if I shot a rocket straight up, would you agree that that's still a right angle with the planet? Like if you launch this way, you're going to go into orbit. Eventually, you're just going to go straight up and you're going to fall straight back down, but that's okay. Can I form 90 degrees here? Is it really just 2 lines though? No, it gets weird when we get here, right? Like there's still this idea of 90 degrees and we could all measure it right here and you would just do the right angle here, just like always. But because it's 90 degrees with a non-flat surface, we have a different word. And the word, and I don't care if you write this down, but the actual word is orthogonal. Instead of perpendicular, we say it's orthogonal to this surface, which is exactly where this comes from. Ortho, not as in bones, but ortho from orthogonal, because we're talking about stuff being perpendicular and the understanding that maybe it's not a perfectly flat surface in the real world. Now, with all that said and done, the orthocenter theorem is super easy to define, and I don't have a good application of it off the top of my head, but we're going to see if we can't find one. So here we go, the orthocenter theorem. The 3 altitudes of a triangle. The 3 altitudes of a triangle meet at a single point, and we could say the same concurrent point, but we're just going to say at a single point this time. Any guess on what it's called? Boom, it's called the orthocenter. Called the orthocenter. That's it. That's our whole theorem. Now, the orthocenter is the place where these guys meet. Now, realistically, this theorem, I don't know how meaningful I would say it, but I'm going to make that one little comment. Can the orthocenter be inside the triangle? So let's check. Here, whoa, right, it does that. So here's my 3 altitudes. If I want it to be inside, what sort of triangle do I need? I need acute. So we'll just make a little comment. Inside when triangle is acute. What's another possibility? On triangle when right triangle. So let's see, if it's acute, it's inside. If it's right, it's on. What if it's obtuse? Outside. Awesome. Outside when triangle is acute. Okay. Nothing too crazy there. Oh, sorry. I said a different word and then I wrote this word. Outside when the triangle is what? Obtuse. And we're going to fix that. Okay. I'm going to make it feel like we're completely switching gears here, okay? Anything crazy so far? This theorem is less meaningful in my mind because all it is just defining it. Like, notice there's no special relationship. There's no equidistance reference. There's no nothing like we had with the other ones. This is just it. Okay, so we're going to do a problem using, and we're going to find the orthocenter, but it's going to feel like we're doing some algebra before we do some geometry. So you'll see why this happens here in just a moment, but we're going to do an example here. But before we get into there, we're just going to say, hey, recall. And we're going to have a huge section to recall. Klein, how do you find the slope between 2 points? Or rather, what letter do we use to represent slope? Because I need an answer. That's not that one. So we'll work this out. I mean, realistically, you could use whatever you want. When I say think of an equation of a line, everybody's probably going to give me the same one. What's the equation of a line? Mx plus b. In mx plus b, which one's the slope, Klein? M. Good. How do you find slope? And that can be anybody. Delta y over delta x. And beyond that, and I'm just going to say equals, not a semicolon. I don't know why I had a semicolon. Equals, how would you find delta y? Y2 minus y1 over. Okay, we have done this year already. Do you all remember it? And if you don't, hopefully we can do it. Okay, so here's one little thing I want us to remember. Here's how you find slope. In this, if I have a point and a slope, can I write the equation of the line? So the answer is yes. Let me rephrase that. If I have a point and a slope, what is the equation of the line? How do I find the line? So mx plus b is slope intercept, which y minus something is what I think I heard. Y1 equals good. Where, just to be very clear with this, m equals a slope. And furthermore, x1 comma y1 is on the line. And again, we've done all this. I'm just trying to remind us of it. Okay, last little thing. I think these are really the ones that we need. One more. If I want two slopes to be perpendicular, I'm going to say m1 is perpendicular to m2 if and only if something's true about them. If I have a slope of 1, that's like this from your perspective, what's perpendicular to that? Negative 1, straight the other way. What if I have a slope of 1/2? 2? Negative 2. We do the opposite reciprocal, or the woe, if you will, every time. Okay, these two are perpendicular if and only if opposite, which just simply means different signs. And what's the real mathy word for flipping a fraction? Reciprocal. I think there's a reason that I'm hitting it hard right now. If it wasn't clear, yes, just for the record. Okay, now the reason that we're doing this, and we're going to keep this all there, none of this is new. You've all saw it in Algebra 1. I'm pretty sure we saw it all this year also. Here's my challenge. We are going to do a problem together, and our job is to find the orthocenter. And Honor, or anybody really on this side of the room, if you want me to close the blinds so you don't just continuously get blinded, I can do that. Would you like me to? Okay, yeah, I got you. Okay, we're going to find together the ortho. Nope, wrong one. Man, I don't want to do study hall. It's beautiful outside today.
Wait, are we gonna have factoring stuff on the final?
Well, like factoring for fun?
No, like
I mean, I could be convinced. Yeah, that's fine.
wait.
I'm messing with you. No. Okay, check it out. Here's the part where algebra hat's on, or at least pretend to put them on. Thanks for digging in. Appreciate it. Here we go. On A, triangle ABC is given as follows. A is the point 0, 0. B is the point, I don't care. What do you want, Jonah? 7, 6. All right. And C is the point 4. I'm going to make it a little bit nicer looking. We're going to say 4, 3. Okay. I want us to find the orthocenter of this triangle. It feels different than every other problem that we've done. Here's the honest truth. We don't really need to sketch it. We don't need to. Do you think it would help? Okay, and I'm not going to sketch it perfectly, but I'm going to give you guys a moment. It does not have to be perfect, which means we don't need like sticky note and stuff. I just want to sketch it. All of these points are in quadrant 1. Here's 1, 2, 3, and 4 for our quadrants. All of these are in quadrant 1 or the origin. So I'm going to draw my scale like that. Here's quadrant 1. And I'm not, do you want me to actually count them since I have the grid, or do you just want me to eyeball it? Okay, 7, 6, about here. Pretty good eyeball, huh? If you don't notice, it's actually 7. All right, whatever. Here's 0, 0. So let's see, well, that's B at 7, 6. Here's A at the point 0, 0. And C is the point 4, 3, roughly there. Ooh, I kind of hate 4. Can we change it? What do you want to change it to? Sure. 8 is doable. 8, 3. No, you're okay. That's like here, right? And I really can't see this one because I'm getting a glare. So I'm just going to say, hey, that's about 8, 3. Does this make a triangle? It does. Now, it's not perfect, but I think I'm pretty sure that this is an acute triangle, but maybe I'm just bad at graphing and it's actually a right triangle, right? Like, I don't know for sure. Doesn't matter. This is just going to help us. Okay. I want to find the orthocenter. To find the orthocenter, I need to find the what's, at least 2 of them. The height, or a better word, altitudes. So we need 2 altitudes because they're all going to meet at the same point. We need at least 2. I don't care which side we pick. Which side is our base right now? There's no right answer. I don't care which one we use. AC is the base. If AC is the base, where would I draw my altitude from? From B. So I'm going to make a note here. I'm going to say if we like the steps, if you like them, here's just a basic overview of it. Step 1 is find equation of 2 altitudes. Now, if we're going to commit to AC being the base, that's fine. I'm totally cool with it. I'm going to organize this pretty specifically. Don't care if you organize exactly like I do, but I do use like subscript and stuff because there's a lot happening here. Like there's a reason I warned you about your algebra heads. So let's check it. If we look at the altitude, and you guys said AC is the base, right? So you could say base AC, or I think this says the same thing, just worded differently. Altitude from B. There's one that we could find. I'm going to find this one. We're all going to find this one together. Then you guys are going to help me, and you're going to find another altitude for me. So let's check it. If I want the altitude from B, couple notes. I can sketch it, and it's not going to be perfect, but I'm not going to trust my sketch. Do y'all agree it's roughly there? Like it's really this, but that looks like it's from B perpendicular, right? That orange line looks kind of like it'd be the altitude. Now, I'm not going to sketch mine. I'm just thinking this out. If I want it to be the altitude, it's always going to form a what angle with my base? A right angle. So whatever it is, slope had better be perpendicular to this. So altitude from B, couple notes. I know that this is perpendicular to AC. Logically, are we all agreed in that? If I'm going to draw my altitude from here, it has to form a right angle with this base because gravity would pull it straight down to that side. Okay, well, how do I find and guarantee that it's perpendicular with maybe some yellow thoughts in my mind? If they're opposite reciprocals. Well, what's the slope of AC? Yeah, I don't know yet either. Can we find it? Let's find the slope M of AC. Now, there's something very convenient about letting point A be on the base. If I want to go from A to here, we don't have to do a whole lot of fancy stuff. Question? Or are you just calling a cat?
Me?
Yeah.
Oh, no, no.
Okay. You good, Riley? Okay. I'm going to claim it's super easy to get this slope. From here to here, how much do we rise? 3. How much do we run? Without doing the calculation, if we get the origin, we can just count it, right? Up 3 and over 8. Now, immediately, this implies that the altitude on the slope, or the slope rather, of the altitude from B, and let's say B alt for altitude, or BALT, if you will, flip that fraction and change the sign. What's my perpendicular slope? 8/3 is the flip. B ALT, B altitude. So I don't care really how you do this, but it's hard to keep straight because we're going to have another one. So I just want some way to be able to say this is from B, this is from the other one. Okay, negative 8/3. We do both. We flip it and change the sign. That's my opposite reciprocal. Opposite, change sign, reciprocal here. Okay, we've just found the equation of the orange line that I had a second ago. Can we find if I know the slope of it? Do I know any point that it passes through? What point? So we now need a 0.76 is what it runs through, and it has this slope. We have a point, we have a slope. Can we use this? So hook it up, help me. Let's find the equation. Y minus, what's the y value of my point? 6 equals, what is the slope we just found?
-8/3.
And x minus, what's the x value of my point? 7. Okay. In the interest of time, I think, and I hope everybody in here can do fractions, but let's see, we're going to get -8/3 x plus 56/3.
Where'd the 6 go?
I'm going to add it here in a second. I'm just dotting. I'm taking a big step. So I'm distributing, right? There's my -8/3 x. Do you guys agree that this is 56/3? And then I'm going to add 6, which is really 18/3. So 56 plus 18 is where I'm at in my head, and I think it's 74. 56 and 18 is 74. I've taken some ... to clean this up. This is the equation of that first altitude. Okay, now, just to be very, very clear, I'm going to make sure, I'm going to call this YB. Yes, sir? Yeah. And I'll even sketch it up here. YB, the line we just found, looks like this. This is line YB right here. YB. We found the equation of that line. Now, a section of this is the altitude, which is convenient. And later this year, when we start dealing with area and stuff, could we possibly find where this actual point meets and then find the distance and actually get the height of my triangle? Eventually, we're going to do that. Like, it's an algebra problem, but we're going to do it in here. Okay, we have found the equation here. Before I say do it on your own, do you want me to show the ... Okay, I got you. So you guys help me come up with the ... part, because I just skipped a bunch of stuff, and fingers crossed we're right. If I want to make this look like y equals mx plus b, which is the most common for everybody, can we all distribute first? Okay, what do I get when I do this distribution? -8/3 x. Careful, what's 8 times 7? Okay, so that's my first step. I've just distributed. And then if I want to go one more step and solve for y, really, what should I add to both sides? Good. So I'm going to write this in a wonky way, but I want you guys to tell me what I've done. I'm going to write +6, and I'm going to write plus 18/3. And it feels like I did something different, but is this also 6? Why would I do it that way? Because I'm making a common denominator just right here and now. And here we go. What's 56 plus 4? And I'm only doing 4 of the 18 right now. 60, and then 14 more. There's my 74/3 that we had. So I just skipped that part. Shouldn't have, my bad. Okay, we have the equation of an altitude from B. Now, in this problem, what I want to highlight, what I would suggest, I'm going to kind of force you to do it one way. The slope was really easy to draw from the origin and to work it out, right? I need another altitude, though. Should I draw it, if I want to be able to get and use the 0, 0 point to help calculate slope, should I draw, or should I use purple altitude, or should I use green altitude? I think it's purple is what I would prefer to go with. And the reason that is it easy to calculate this slope on AB? What is the slope from A to B? Nope.
Or 1.
How far up?
7.
Nope, there's only one of them. Which one of these is 6 up and 7 over? That's why I would use that. Okay, it's up 6 over 7 from here to here. So maybe I phrased that question wrong. Like, if you're goofed up, and I might have phrased it weird, do we all agree it's easiest if this is the base? Let's just commit to that, which means my altitude would be drawn from where? So what I want you guys to do is I want you to come up with the equation for the altitude from C. We did it from B right here. I want you to do it from C on your page. Cool. Why'd you do that? Oh, I got you, man. Don't worry. I'll show it to you. Yeah, you can look at that one. That's fine. Okay. So do it. That's you guys. I'm here to help, but I think collectively we can probably get this done. You are finding the equation of a line. That's it. Go. Talk it out. Get loud. Get crazy. I will help. Don't just wait for me to do it. I can do as much of it as you need me to, but help me out here. What is the slope if it's perpendicular this time to AB?
-7.6.
-7.6. Are we all in agreement with that? Okay, M of the altitude from C, so I'll do the same thing, C altitude is equal to -7.6. We all on the same page? Through which point? Yeah, A3. Okay, so let's plug and chug. Let's see what we wind up with. Y minus 3 is equal to -7.6 and x minus 8. Do we all agree with that? Okay, so here's the difference, and I didn't see it on yours. This one's over thirds, this one's over 6. That's where the difference is going to happen. Like they're all the very similar numbers, but these are over 3, these are over 6. So let's see if it happens here. Okay, help me distribute. Y minus 3 equals what? Plus, okay, decision time. I need to add 3 to each side, right? Alternatively, I noticed something about this. They're both even. Should we simplify this fraction just now, or do you want to do it in the end? Now is easier, just so you know, because the numbers are smaller. Let's do it now. It felt like a question. It wasn't really. Okay. What goes into both of them? 6 goes into 56? So I don't think 6 works. 3 times 17 is 51. 18 is 54. That's not true either. 2, Will. 2 times what? So 25 gets me to 50. That's right. It's 28 thirds. Okay. Notice, I'm not erasing it. I just crossed it out and we just replaced it. Like we're here, we might as well. Now, what do we add to each side to solve it for y? Okay, so I'm going to add 3 to this side, and I'll write it as plus 3. How would you suggest I write plus 3 on this side? Knowing that it has to be over 3 anyway. That's also 3. So here we go. We get the equation for the altitude from C this time, and I'll call it y sub C. Let's see, it's -7.6x plus 37 thirds. Okay. It's different now that we have the same denominator, and I didn't notice it because all the numbers are oddly the same, pure coincidence. Okay, so what we've just found is the equation of this line. So that's y sub c. Here, we are going to put all the algebra together. Do my two altitudes cross? Now check this out. I know I use subscripts, but here we have y equals something, and here we have y equals something, right? They're both equal to each other at this point. Could we just set both of these equations equal to each other? And that's exactly what you're going to do for this evening. So our last little step here is once we get to this, we find two altitudes. We found both equations, and I'll label this one YB. So step 2 of this process, if we're only calling it 2 steps, is set YB equal to YC. And I'm even going to help you one step further. It means very specifically the equation that you get to solve is when for which x value? Is it true that negative 8/3 x plus this equals, how do we write yc? Okay, here's my algebra advice for you. Before you do anything, can we all agree that fractions are worse than not fractions? It's going to feel weird. I want you to multiply. This is what I would do for my first step if I were you. I would do both sides. Algebra says if I do the same thing to both, we're fine, right? I would multiply this side by 6 and this side by 6. We're going to bust them fractions. Cool. Peace out. Bring me this answer tomorrow. So just, and we'll talk, but wrestlers, just so you know, and wrestlers, if, yep, Klein and Chelsea, or yeah, just so you guys are aware, because I heard Gian say one more period. You're right. You have one more period of being in school. Even if you make state, are you still expected to watch videos and take notes and do all the stuff that we're doing? So really, you have 7 more days of school. I won't get a chance to check it. Hopefully, you guys don't come back. But you need to keep doing your stuff, okay? Like, for sure. Okay. I don't know that is. Maybe. Hey, also, check out the thing on the backboard.